So the TCP/IP model was developed prior to the OSI model. It is not exactly similar to the OSI model. This consists of 5 layers such as application layer, transport layer, network layer, data link layer, and the physical layer. The first 4 layers provide physical standards, network interface, internetworking, and transport functions that correspond to the first 4 layers of the OSI model, and these 4 layers are represented in TCP/IP model by a single layer called the application layer. This is a hierarchical protocol made up of interactive modules, and each of them provides a specific functionality. So what is a network layer? A network layer is the lowest layer of the TCP/IP model. A network layer is the combination of the physical layer and the data link layer defined in the OSI reference model. It defines how the data should be sent physically through the network. This layer is mainly responsible for the transmission of the data between two devices on the same network. The function carried out by this layer are encapsulating the IP datagram into frames transmitted by the network and mapping of IP addresses into physical addresses. The protocols used by this layer are Ethernet, Token Ring, FDDI, X.25, and the frame relay. So what is an Internet layer? It is the second layer of the TCP or IP model. This is also known as the network layer. The main responsibility of the Internet layer is to send the packets from any network, and they arrive at the destination irrespective of the route they take. The next one is transport layer. This is responsible for the reliability, flow control, and correction of data which is being sent over the network. The next one is the application layer. This is the topmost layer in the TCP or IP model. It is responsible for handling high-level protocols, issues of representation. This layer allows the user to interact with the application. When one application layer protocol wants to communicate with another application layer, it forwards its data to the transport layer. There is an ambiguity occurs in the application layer. Every application cannot be placed inside the application layer except those who interact with the communication system. When most non-technical people hear the term 7 layers, they either think of the popular Super Bowl bin dip or they mistakenly think about the 7 layers of hell courtesy of Dante's Inferno. For IT professionals, the 7 layers refer to the Open Systems Interconnection or the OSI model, a conceptual framework that describes the functions of a networking or telecommunication system. The Open Systems Interconnection model is a conceptual model created by the International Organization for Standardization, which enables diverse communication systems to communicate using standard protocols. In plain English, the OSI provides a standard for different computer systems to be able to communicate with each other. The OSI model can be seen as a universal language for computer networking. It's based on the concept of splitting up a communication system into 7 abstract layers, each one stacked upon the last. Although the modern internet does not strictly follow the OSI model, the OSI model is still very useful for troubleshooting network problems. Whether it's one person who can't get their laptop on the internet or a website being down for thousands of users, the OSI model can help to break down the problem and isolate the source of the trouble. If the problem can be narrowed down to one specific layer of the model, a lot of unnecessary work can be avoided. So the 7 layers of the OSI model are the physical layer, the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer.